Okay, so now for number 6, just clear this frame. So number 6 is going to be x 16, 32, 54, y 116, 156, z, and we continue. So the first thing is to determine a general formula is what they want. So there are probably many ways of doing this, but what I'd do is I'd list the first differences up to a point. Okay, so I'm just listing them, minusing the right from the left every time. And then we can see what we end up with. So the problem now is I don't have this first term, don't have this first difference like I would usually use. But what I do know is it's quadratic. They've told me this. So I know this must be a constant second difference. So this is just going to be 16. Let me just calculate it on the side, right? So this is just going to be 16 minus x. So in other words, it's just going to be x. It's going to be the same difference over here. Okay. And then over here, we do have something. We can say this is a difference of 6. These ones, if I really wanted to, I can go and calculate them, but they're all going to be in terms of variables. So I'm not even going to do the effort. Now, what I can note is that it's got a constant second difference. So x must be equal to 6, okay, because x is also a second difference. This already helps me because now I can solve for this one up there and say, therefore, our first difference must be 10, 16 minus 6. So therefore, 3a plus b must equal to this, and we know that 2a must equal to our second constant difference. So this means a is equal to 3. So if I substitute 3 in there, 9 plus b is equal to 10, and I can just solve for b to be equal to 1. And now a plus b plus c must equal to x, which we said is 6. So a is equal to 3, b is equal to 1, must add up to 6, so c must be equal to 2. Okay, so once I've solved for a, b, and c, I've already solved for x in doing this. I can just say my general formula would then be 3n squared plus n plus 2. We can quickly see if we substitute in 1, it would be 3 plus 1 plus 2 is 6, which is what x was. Okay, if we substitute in 2, we'll say it's 3 times 4 plus 2, which is in fact equal to 16. So we do get our second term and your third term and so forth. So you can quickly test if this makes sense, and it does. Okay, so our next question becomes to solve for the unknowns, x, which we already solved for in doing this, term 1, and then term 2, 3, 4. Y is just equal to term 5. Z is just equal to term 6, 7, 8. So I have two different ways I can go about this. I can just say y is equal to term 5, and then just say, okay, term 5 is just equal to this formula with 5 substituted in. No brain power required, and I can quickly solve using a calculator. Z is just equal to term 8, and that would just be equal to 8 substituted into this formula. No brain power required. I just use a calculator and I get this. The other way I can do this is I can say, okay, this constant difference is 6. So y minus 54 minus 22 is 6, and then solve for y. or I can say, okay, this difference is also 6, so z minus 154 minus 40 is equal to 6, and I can solve for z. Any of those methods would work. There's even different ways you can go about it still, but you should get an answer of 82 over here. Let's just see, does 82 make sense? 82 minus 54, is that going to be 6 more than this? The other way we could do this is we'd know we're adding 6 each time, so 28 must be our next difference, so it's just going to be 54 plus 28, which is in fact 82. Okay, where we can solve z as well as we can just say, okay, so the difference was 40 between those two. The next difference must be 46. So 156 plus 46, it should be equal to 202. And then we can just confirm that this 3 times 64 plus 8 plus 2 is 202. So all our methods get the same answer. Whichever you prefer to do would be fine. Okay, so this was question 6. Question 7 then is, okay, question 7. Wow, I can zoom even more. Okay, cool. So question 7 is then the 8th term, the 9th term, and the 10th term of a sequence. So we left with 1 comma, and then we leave a blank space. Then we say term 8, term 9, term 10. And what we get is that term 8, they said, is negative 15. Term 9 is negative 8. Term 10 is 1. Dot, dot, dot. So first thing we can look at is there a constant difference over here? Okay, so 1 minus 8 is going to be 9, minus 8 minus 15 is just going to be equal to 7, right? So this is not a constant first difference. Okay, in your tests, you'd know, that this thing means, okay, it's not a constant first difference, so it's going to be a constant second difference. In reality, it could be much more difficult, but let's say we accept it's a constant second difference just because we're in high school. And then, I don't like this problem in case you can't tell, we can say that this is then our a value. Okay, so I would in a question, or 2a value, I would in a question just tell you that this is in fact quadratic, because otherwise we don't exactly know if that's the case. So a must be equal to 1. Okay, cool. So we have the first difference. So we can work backwards to get to term 1 if we want, or we can use different methods to get our answer. We have the a value, okay? So if we want to work backwards, we can go all the way back and say, okay, then this difference must be 5, and this difference must be 3, and dot, 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 until we get back to 1, and then we can solve it the normal way. It's not too much work. It's just going to be 7 different things we calculate like this. So the other method would just be to say, okay, we're not going to do it that way. Let's see what other way would work. So let me just quickly pause and see what the easiest way would be for you to solve this. Okay, so the easiest method would just be to go and substitute in that we know that term 8, for instance, is equal to, what was it, 15, negative 15. So we can just say term 8 would also be equal to just 8 squared. We know a is equal to 1 plus 8b plus c. This is negative 15 is 64 plus 8b plus c. So we can just get b in terms of c, or however we prefer. Let's just get c alone, and so it's going to be negative 15 minus 64 minus 8b. I now have something in terms C in terms of B. So if I do that quickly, it's just going to be minus 79, right? Minus 79 minus 8b. Okay, cool, this is nice. What I can also do is I can say, but we also in fact know term 9 is negative 8. Okay, so term 9 is 9 squared plus 9b plus c. This is negative 8. So we can say this is equal to 81, whoops, 81, not anything else, 81, plus 9b, and then c is equal to negative 79 minus 8b. This is nice because now all I'm left with is 81 minus 79, which is 2, and 9b minus 8b, which is b, is negative 8. So b must be equal to negative 10. So now I've solved for b. To get the answer for c, I can just substitute this back into there and get that c is equal to negative 79 minus 8 times minus 10. So it's 79 plus 80 is just 1. So we have a, b, and c solved. So Tn would just be equal to n squared minus 10n plus 1. And we can test that it works as well. Okay, what other questions did you get based on this? So this one was a determine. So this was just to determine the formula for the nth term. So this would be my answer. Okay, so the very last question then becomes question 8. Okay, question 8 is just going to be the second term of quadratic sequence is 1, so t2 is equal to 1. The third term is equal to negative 6. Okay, and the fifth term is equal to negative 14. Okay, so there's obviously 3 equations, 3 unknowns, so I can do the simultaneous equation style. What I can do as well is I can just say we don't know this one, we know this is 1, we know this is negative 6, don't know this one, we know this is negative 4. Before even going into simultaneous equations and making it difficult, let's just see, we have some first difference here, negative 7. Fortunately, we have nothing else to do anything with. Okay, so first thing I can note is this is my general formula. So if I say T2 is equal to, and it would be A times 4 plus 2B plus C. Again, this is equal to 1. So I've already got one equation in terms of all of my variables. Okay, I then have something else. I can say term 3 is equal to. Okay, so I've listed the 3. I just said term 3 equal to this, substituted in the value of term 3. Term 2 is this, and term 5 is this. Now I have 3 equations. Okay, what I can notice about this is it's quite nice that this one is 3b and 2b, and this one's 5b. So I can actually say what would happen if I add a and b together and I subtract from that c. Let's see what happens. So if I add a and b together, I get that a was negative 6 is equal to 9a plus 3b plus c. B is 1 is equal to 4a plus 2b plus c. And then I want to subtract from that. This negative 4 is equal to, so if I want to subtract, let's just write it as subtracting this. 5b plus c. Okay, so in essence now I'm just subtracting c from it, so I'm adding them all together. and then what I'd get is negative 5 plus 4, right? It's going to be negative 1, right? So negative 1 on this side, I get, sorry, this is then negative c, right? So then I cancel out the b's, and I'm left with 9 plus this is 13, so it's what, negative 12a plus c. So at least now I have something a bit simpler in terms of only two variables. Okay, there's different ways of doing this as well. Okay, but now I can get, let's say, c in terms of a, and I can call this one, let's not call that one star, let's call this one star. Okay, cool. So now I have something nice. I have c in terms of this. What I can now do is I can say, okay, well, if we look at two different subtractions, and you can look at the other solution that was posted, it's going to be a different way of doing this. If I just do a and subtract from a b, what am I going to be left with? If we look at a and b, it's going to be minus 6 equal to 9a plus 3b plus c. I'm going to subtract from it b, so let's write down negative b, so we just add them together. Negative 4a minus 2b plus c. Okay, so this is something way different, so I'm going to get two things in terms of each other in a different way. This time, sorry, it should be minus 2b and then minus c as well. Okay, so this is minus c, so if I add these two together, I get negative 7 is 5a plus b, and then those things vanish. So now I can also get b in terms of a, and so it's negative 7 minus 5a. Okay, so now I've gotten two of my little things in terms of a, and now I can just substitute in any of those equations. I'm going to choose the one that looks simplest, so I'm going to use b, that is just 1 is equal to 4a plus 2b plus c. Okay, so this is equation b. I'm just going to sub in both star and double star. So 1 is equal to 4a plus 2 times, and b is negative 7 minus 5a. Okay, plus then c, which is 12a minus 1. Okay, and I can get something like 1 is equal to 4a minus 14 minus 10a plus 12a minus 1. Okay, so this is 10a. So then I get 2a, 6a in total, and I get negative 15. If I take it over, it's 16. So a must be equal to 16 over 6. Let me just check that all of that is logical. Okay, cool. So if I've solved for a, what I can then do is I can go and use this value for a to substitute back into double star to get b. Then I can get b is equal to negative 7 minus 5 times 16 over 6, and solve for b. And I can solve for c as well. I'm quickly going to write the solution. Okay, so then on this, like I said, after we've solved for a, we can substitute back into this. We can get this as an answer. Negative 61 is over 31. We can look at equation star up there to get c. We can substitute back in and we can get an answer for c. And then we've solved for a, b, and c, so we have our general formula. Okay, so this would be our general formula. One thing to note is I just realized I read the question incorrectly. So I read this as negative 4. That's what I solved for. So for this specific pattern, this is 100% the correct solution. Your question actually had 1, negative 6, and negative 40. the solution for this one is the one Mr. Moody posted the photo of, and it has a different method, and I think a much simpler method for most people to understand. If you like dealing with three different equations, doing simultaneous equations and getting a solution like this, that's 100% correct. This is how my brain works. I think most of you will find the method on Google Classroom simpler though. So go and look at that for this problem. It's a very similar problem. The fifth term is just a bit different because I read my question incorrectly. Okay, cool.